So this is going through another set of examples for partial fractions. I'm going to do all 4 different kinds again. So we're going to start off with distinct linear factors. And I'm just making this up, so hopefully it works out okay. So I think this one's a little more difficult. And I'm going to go ahead and factor. I'm just going to do the factoring. Already. So if I had whatever this multiplied out, I would factor it. These are distinct linear factors because they're different. And in that case, you have 2 constants you're trying to figure out. A, which goes with one of the linear factors, and B, which goes with the other linear factor. And, does it make any difference whether A goes with x plus 5 or B with x minus 1? The answer is no. It's just they would switch. The values would switch if you switched their place. But as far as you don't have to have any rule that says I need to stick A with the biggest one or the smallest one. Okay, so what we did was when you have 2 distinct linear factors, you can just cross multiply these and then multiply these together. It's just a little quicker than having to write out x plus 5 times x plus 5. So we're going to take this one, multiply it by that one, and then do the other way, b times x minus 1. And as a consequence, we have this is the common denominator, which matches now the left-hand side. Okay, so then we set the numerators equal to each other. And we don't multiply it out. I mean, you could, but it's just a lot easier doing it this way. So what you're going to do is you're going to let x equal 2 values. And again, you could pick any 2 values for x, and then you have 2 equations and 2 unknowns. But if we choose x to make this factor go to 0, which happens when x equals negative 5, and x equal to whatever makes that go to 0, which would be positive 1, what that'll do is just simplify things down. So we now plug into the left-hand side. So you have negative 4 times negative 5 minus 7 is equal to a times negative 5 plus 5. So that gets rid of that term, plus b times negative 5 minus 1. And let's just finish this one out. So 4 times negative 5 is negative 20. Minus 7 is negative 27. This goes to 0. So we're just left with b term, negative 6. So b is equal to negative 27 divided by negative 6, which is 27 divided by 6. 27 is 6. Okay, and then I'm going to do this one here. So if we let x equal 1, I'm just going to write 0 out. And actually, it's not when x equals 1, not negative 1. I put that in there. X equals 1. Okay, so I'm going to put x equals 1 there. That goes to 0. So you get 4 minus 7, which is negative 3. And 1 plus 5 is 6, so you get 6a. A is equal to negative 3 over 6, which simplifies down to negative 1/2. So the answer is, we have a, which is negative 1/2, so you'd have negative 1 over 2 times x minus 1. So that's negative 1/2. And in the second part, b was 27/6, 27b over 6 times x plus 5. You could also write this as negative 1/2 times 1 over x minus 1 plus 27 over 6 times 1 over x plus 5. Either way. From a calculus standpoint, this is probably a better way of doing it. Okay, so that's another example of distinct linear factors. Don't get two equations and two unknowns. Choose x judiciously to solve one equation and one unknown. Let's go to repeat linear factors. So I'm going to do negative 2x plus 3 divided by x plus 2 squared. So now our linear factor is x plus 2, but there's two of them. So what happens there is we have a divided by x plus 2 plus b divided by x plus 2 squared. So to get a common denominator, all I have to do is multiply this first part by x plus 2 in the numerator and the denominator. So you get a times x plus 2. We don't have to do anything with the b because it already has the right denominator. So that's that. So now we have the same denominator, so we can set the numerators equal to each other. And again, we can judiciously choose x. So one choice for x is to make this to go to 0. So that happens when x equals negative 2. And the other one, we just let x equal 0. So we'll get negative 2 times negative 2. Negative 2 from here, negative 2 from there, plus 3 equals a times 0. Negative 2 plus 2 is 0, plus b. So we get b is equal to 7. So negative 2 times negative 2 is 4. 3 plus 4 is 7. Okay, then we set x equal to 0, which means that term goes to 0. So you get negative 2 times 0 plus 3 is equal to 2a plus b. So what it is, I set this equal to 0. So 0 plus 2 is 2. 2 plus a times 2 is 2a. And this is going to drop out, so we end up with 3 is equal to 2a plus b, which is 7. So now I take this and plug it in there. We subtract 7 from both sides, we'll get negative 4 is equal to 2a, or a is equal to negative 2. Negative 4 divided by 2 is negative 2. Okay, so the answer is a, which is negative 2. So we get negative 2 from here over x plus 2 plus b, which is 7, divided by x plus 2 squared. And that is the same as negative 2x plus 3 times x plus 2 squared. And again, these are things that we can solve using calculus, which is the other ones we can't. Okay. Next is a quadratic factor. Typically we have a linear factor in here. Otherwise there'll be no difference. So let's do x plus 1 times x squared plus 5. Now, one thing is, can you, before we do this one, don't write this down. Can I do, if this is not factorable, which I don't think it is, meaning you can't get real factors. Would I do this? Does it always have to be x squared plus or minus plus a constant? And the answer is no. So if I were to do this one, and we'll do it in calculus, but we're not going to do it right now. Just want to introduce you to the whole idea. You would take the entire quadratic that has no real zeros and make that the denominator, and then have bx plus c as the numerator. But like I said, we're going to do the easier ones right now. So you take the quadratic term that's factored. And again, I can't factor this because it's added with a square root of negative something. So the linear term just has the coefficient a, and the quadratic has ax plus b. Okay, so it's kind of like with distinct linear factors. You can cross multiply here. So you'd have a times x squared plus 5 plus bx plus c times x plus 1, all divided by the product of those two, which just gets us back to the same denominator as we originally had. And we got to figure out what a, b, and c are. Now, the question is, what is the question? I don't know if there is a question. We're just going to do it. So what we get is 4x minus 2 is equal to a times x squared plus 5 plus bx plus c times x plus 1. It looks kind of like a 7, but it's not. It's a 1. So we multiply out the right-hand side. So we'll get ax squared plus 5a. Okay, that was easy. Just a times each one of those. And then we use FOIL. Bx times x is bx squared. C times x is cx. Bx times 1 is bx. And c times 1 is c. So we group the terms, and I'm also going to add a 0x squared to the left-hand side. So we got ax squared and bx squared. So we have a plus b times x squared. Then we have cx and bx, so that's going to be b plus c times x. And we have 5a plus c. And then we can write 3 equations for the coefficients associated with the 3 types of terms. So when you have 0 on the left-hand side for x squared. You have a plus b on the right-hand side. For x, we have 4. And on the right-hand side, we have bx plus c. And then we have negative 2 is equal to 5a plus c. And you can see that we're going to have 3 equations and 3 unknowns. So how do we do this? Well, and I'm not going to give you one harder than this. You can use substitution. And what we're going to do is we're going to solve this first equation for a. So you get a is equal to negative b. And I'm going to solve the second one for c. C is equal to 4 minus b. So I'll subtract b from both sides to solve for c. Here I subtract b from both sides to solve for a. And then I'm going to substitute into the third equation. So this is a function of a and c, but if I plug in a is equal to negative b, and c is equal to 4 minus b. Now, instead of equation in 2 variables, it's going to be an equation in 1 variable, which is b. So let's multiply everything out. So you get negative 2 is equal to negative 5b minus b from here, plus 4, subtract 4 from both sides, you get negative 6 is equal to negative 6b, b is equal to 1. That was convenient. Okay, and then once you have b solved for, you can go back here and find a is equal to negative 1, negative b, and c is equal to 4 minus b, which is equal to 3. So that was very convenient. So now the original expression becomes a, which is negative 1. So you get negative 1 over x, the linear factor, which was x plus 1. And then you get plus b, which is 1. 1 times bx, so 1x. And c was equal to 3 plus 3 divided by the quadratic term, which was x squared plus 5. So you get 1x plus 3. Here you get negative 1 over x minus 1. So clean that up a little bit. You get negative 1 over x plus 1 plus x plus 3 over x squared plus 5. And that's the same as the original expression here. Okay, so we've done distinct linear factors. We've done a quadratic factor with a linear factor. So we've got repeating linear factors, but I'm going to make this one slightly different. Hopefully this works out, just because I'm just making up numbers here. And I'm gonna show it as already factored. So what I'm going to do is to have two repeat factors in one distinct factor. So what you do when you have more than two factors in the denominator is you're going to just kind of keep, well, let me just explain. If I had three separate factors, then I'd have a, b, and c with the three factors in the denominator. But when you have a distinct linear factor and two repeat factors, what you do is you take a constant, divide by the single factor, then you take constant b, divide by the second factor, and then you take a constant c divided by x minus 2 quantity squared. So this is the repeat factor and this is the distinct factor. Okay, now so this is not quite as easy as far as coming up with the common denominator. You know, this one I have to multiply by x minus 2 squared to get this whole thing. This one I have to multiply by x minus plus 1 and x minus 2. And this one I have to multiply by x plus 1. So let me just show you how this works. So you're going to have constant a. It already has this part. So you're going to have to multiply by x minus 2 squared. And then you divide by the whole big denominator. Okay, you can see those cancel out. We come back to where we started. Constant b, you're going to need x plus 1 and x minus 2 divided by x plus 1 times x minus 2 squared. So these cancel out, and one of those cancels out, and that gets you back to here. And then finally, this one's already squared, so all we have to do is multiply by x plus 1 in both the numerator and the denominator, like that. So we have the common denominator now, and so we can put all these numerator terms together into one single numerator, and then we have this common denominator. And now we have the same denominator on the left-hand side of the equal sign and the right-hand side of the equal sign. So at this point you can set the numerators equal to each other. Like that. And then we can, I'm just thinking here. So can you just set x equal to either positive 1 or negative 1? I mean positive 2 or negative 2 or negative 1 to get rid of those and solve. I think so. Yeah. So let's do it in this form first. So rather than multiply this all out, I think it would be easier. What we'll do is we'll let x equal 2. And what that does is that makes that go to 0, and it makes that go to 0. So the only term that's left is this last term. So we substitute x equals 2 into the left-hand side and into the right-hand side. These two terms, this term goes to 0 and that term goes to 0. So we'll have 6 plus 4 is 10, and we've got 2 plus 1 is 3. So c is equal to 10/3. Then we can let x equal negative 1. What that'll do is make this term drop out and this term drop out. So you've got negative 3 plus 4 is 1, and negative 1 minus 2 is negative 3. So you get a is equal to negative 1/3. Okay, so that's a and b. And then what you can do is you can, we know a and c, we know a and c, so all we have to do is solve for b. We can pick any value for x other than these two. We need to pick a third value, so probably just pick 0. So if you do that, you get 3 times 0 plus 4 on the left-hand side, and here you'll have 0 minus 2 squared. Negative 2 squared is 4, so we get 4a. Here we'll get 0 plus 1 and 0 minus 2, so that's 1 times negative 2, which is negative 2. So you get negative 2b, 1 times negative 2. And then the third one, you get 0 plus 1, which is 1, so you get plus c. So all I have to do now is plug in our known values for a, which is negative 1/3. And we don't know b, so we're going to solve for that. Plus c, 10/3. So we'll have 4 is equal to negative 4/3 plus 10/3 minus 2b. 4 is 12/3. If you multiply by 3, divided by 3, you'll get 12/3. Here we have 4/3 plus negative 4/3 plus 10/3, which is 6/3 minus 2b. If we subtract 6/3 from 12/3, we'll get 6/3, which is 2. That's equal to negative 2b, and divide by negative 2, you get b is equal to negative 1. Okay, so those are the values for a, b, and c, and then you could go back and plug those in here, and then you'd have what you're looking for. And the final one, this is beyond what I would ask you to do for a test, but I just want to give you an idea of what to do here. Just a complicated one. So what we're going to have is we're going to have a linear factor and a quadratic factor squared. Okay, we've already done the linear factor and the quadratic factor, so this is different, and then we have a repeat quadratic factor. So the way you would set this up is you would have a over x plus 1, that's the linear part, and then you'd have bx plus c divided by x squared plus 4, and then you'd have cx plus d divided by x squared plus 4 squared. So it's like with the repeat linear factors, except and I repeated a letter here, so let's fix that. A, B, C, D, E. And I'm not going to work through this whole thing, but this one I would have to multiply by x plus x squared plus 4 squared to get this denominator. The second part, I'd have bx plus c times x plus 1 times x plus 4, x squared plus 4, and the final term I'd need to multiply the dx plus e. I'd have to multiply by x plus 1. All of those terms would be divided by x plus 1 times x squared plus 4 squared. So I take this one, multiply by that to get that. This one, I multiply by this and one of these so I can get a squared. And the last one has a squared part but doesn't have a linear part. So what you do, the way you do this is you have 5 constants, a, b, c, d, and e, and you would multiply this whole thing out and get x to the 4th terms, x cubed terms, x squared terms, x terms, constant terms. You'd have 5 equations of 5 unknowns, and it'd be difficult, but that's the way it goes with these.